right, so our lesson today is going to be an introduction to what we call imaginary numbers. So in a bit, we're going to go over what an imaginary number is, what a complex number is, and then we'll do some introduction problems with that. It's going to link in with that lesson we did before our quiz on simplifying radicals. So we're going to start with a couple warm-up problems on this. Okay, so let's do these. So if we look at 1 square root of 32, remember the idea of simplifying a radical is we're going to break this down into the factors that multiply together to make that number. If we're looking for if it's a square root, we want two of the same number. Okay, reminder that the reason we want that is, let's say we could break out a square root of 3 and a square root of 3. Well, square root of 3 times square root of 3 is now 3. Okay, so we're trying to bring out any whole numbers we can to simplify the number inside the radical to the smallest number possible. So we just start breaking this down into factors that multiply together to make this number. So if we have 32, maybe we start with 8 times 4, and then we keep going. Okay, so this 8, well, that's 4 times 2. Okay, from here, you could recognize you have the two 4s here. Okay, and those are the same. Okay, so I could say, 4 and 4. So we're going to pull that out. 2 can't be broken down any further. So I would have 4 root 2. Might be thinking, well, why didn't I break down that 4 further into 2 and 2? If I did 2 and 2 and 2 and 2, I would have 2 pairs of 2s. And I would have 2 times 2 times our extra 2 that's left over, root 2, which would still be 4 root 2. Okay, so if you broke that down further, you would still get to that same answer of 4 root 2. Okay. 2, square root of 121, just threw that one in there. Sometimes you're going to have a perfect square. Okay, so remember, 121 is a perfect square. So that breaks down into 11 times 11. Right, if that's the case, well, these are both perfect. These are the same number. We could just write this as 11. Okay, so that would be our answer. Be no radical left over. We also did ones where we had numbers in front, like 2 root 46 or negative 3 root 50. So if we were simplifying 2 root 46, we're not going to do anything with the 2 in front. We're just going to break down this 46 into its factors. If you don't know your factors of 46 off the top of your head, maybe you start with 2 times 23. Well, from there, we keep going. Well, 23, there's actually nothing that can go from there. Okay, so if we look, we have no pairs. So I threw this one in here because sometimes it doesn't factor. Right, there's nothing else we could do because this 23 doesn't break down any further. So our answer would actually just be 2 root 46. Can't be simplified any further. Okay. Then 4 root 50, we want to break that down. So we could go to 25 and then 25 we could break down to 5 and 5. Well, there we have a pair. Okay, remember the 2 doesn't have anything that goes with it. So this negative 3 is still going to be in front. So negative 3 times, we have 2 5s, that makes up just a 5 without the root, and then a root 2. And then we can simplify. Negative 15 root 2. Okay. So we did that last week, day before we started reviewing for our quiz. Okay, and that's going to come up again today. Okay, so we're in our textbook. We're on page 54. Okay, so you can just kind of shorthand write these notes down. So again, we're on page 54. A real number that's a set of rational and irrational numbers. That's everything you've ever worked with in math, right? Examples of real numbers: 5, negative 7, 2/3, things like that, right? They're just normal real numbers. An imaginary number is something we haven't really seen before. It involves the unit I. Okay, I is equal to the square root of -1. That's our big idea for today. You're going to see that over and over again. So an imaginary number is in the form b times I, where b is a real number and I represents the square root of -1. So examples of imaginary numbers: 3i, -7i. Okay, and we'll see it over and over again today. I represents the square root of -1. A complex number, it's in the form a plus b times I. So it has a real component, a, and an imaginary component, b times I. Okay, so examples of complex numbers, that'd be something like 5 plus 4i, or 7 minus 6i. Okay, there's a real component, the real number in front. There's an imaginary component at the back. Okay, so today in our introduction, we're going to start by identifying the real and imaginary component real quick. Then we'll go through some kind of intro problems with imaginary numbers. Okay, so page 55, real simple one to start with. Identify the real and imaginary parts of this complex number, 8 plus 1/3 I. Okay, the real component, well, first off, remember every complex number is in the form a plus b I, where a is the real component, b times I is the imaginary component. So here the real component would just be the number in front, 8. The imaginary component would be the part at the back, 1/3 I. Okay. Some quick ones. You could write these down. You don't need to write all the extra stuff. So if we have 3 plus 6i, well, the real component would be the 3. The imaginary component, 6i. Not always so simple. If we looked at 2, or if our expression was just -15i, well, the real component, there isn't one. The imaginary component, -15i. Versus if we looked at one like 3, if our expression was just 20, the real component, well, that'd be the 20. Imaginary component, we don't have one. Or in 4, real component, -10. Imaginary component, -2i. Okay, so first things first, if we're given a complex number, then we want to be able to identify the real or the imaginary component. Now, notice not all these are complex numbers, right? In this case, the only ones that were complex numbers were 1 and 4, right? 2 is just an imaginary number, 3 is just a real number. Okay, so we're trying to also, as a side note, get comfortable with that vocab: real numbers, imaginary numbers, complex numbers. Okay, before we get into our next example, so we're going to be rewriting expressions as radicals, almost working backwards from what we've been doing in the past. So what we have to remember is we could take a whole number, something like 4, and we could rewrite that as a radical. The way we would do it without changing the actual value of the number would be to square the number and then put the radical on the outside. Okay, so 4 squared would be 16. So notice 4 is the same as square root of 16, because square root of 16 is 4 times 4, so we have 4. Okay, so if we're given just a number, we could rewrite it as a radical by squaring the number, okay, making this 49, and then putting the radical on it. Okay, so 2, we could rewrite that as, well, 2 squared, that's 4, square root of 4. We could rewrite 9 as square root of 81. We could rewrite 12 as square root of 144. Okay, so this is just a pre-example as we go into example 2. Okay, so example 2. So now we're going to rewrite this complex number using a radical. Okay, so our complex number is 2i. So key idea to remember is that I is the square root of -1. Okay, first off, before we get into this, if you're thinking, why is I an imaginary number? Well, it's because you can't take the square root of -1. right? There is no number that multiplied by itself would give you -1. Okay, that's where the imaginary units are coming from. Okay, the fact that you can't take the square root of a negative number. Okay, so the way we're going to do this, we need to rewrite both the 2 and the I as a radical. Well, remember, I is just the square root of -1. We're going to rewrite 4 as a radical. Remember, 2 squared is 4, so we could rewrite that as the square root of 4. From there, we just want to combine these. Okay, so we can actually just multiply the numbers on the inside. So this is the same thing as square root of -4. Okay, it's the same thing as square root of -4. So square root of -4, same thing as 2i. Okay, let's do some practice problems with this. Sorry. Okay, so still on the same page, rewrite the complex number 3i as a radical. Okay, so same idea. Remember, I represents square root of -1. So we need to rewrite each piece as a radical. So 3, we could rewrite that as the square root of 9. And I, we could rewrite that as square root of -1. So then putting those together, we multiply the numbers on the inside, square root of -9. Okay. One more. So now we have a number in front and a radical. So this root 2 is already as a radical. So really our job is to rewrite the 4 and the I as radicals and then put them all together. Okay. So 4, we could rewrite that as square root of 16. I, we could rewrite that as square root of -1. And then root 2 is still root 2. Now we put all these together. So we're going to multiply 16, -1, and 2. Well, that's going to be -32. So we have square root of -32. Okay, so that would be our whole expression rewritten as just one radical. Okay. We did these as a warm-up. Why don't you guys get some practice right now and do these two, and then put your answers into the video. Okay, let's see how we did. Okay, so I'm going to give myself more room. So square root of 45. Start with that one. Well, I could break that down to 9 times 5. And I could go further, 3 times 3. Now I have my pair. So square root of 45, that would be 3 root 5. Now let's do square root of 98. Personally, if I don't know my factors and it's even, I start with 2. So 2 times, it's actually 49. We like that because 49 can break down into 7 and 7. We have a pair there. Can't go any further. So my answer would be 7 root 2. Okay. So where are we going with this? Well, now we're going to simplify radicals where we have a negative number inside the radical. Okay, so the only thing we have to remember now is square root of -1 is I. So we're going to start by breaking this out. Okay, so we're on example 3 now. Okay, so square root of -32. First thing we're going to do is we're going to bring out that square root of -1. Okay, so now this is really just square root of 32. Remembering that square root of -1, that's just I. Now we're going to rewrite root 32. So let's break that down. So maybe we go 8 and 4. And keep going. 4 and 2. We actually saw this one earlier. Okay, so remember the 4 is matched up. So now we really have 3 pieces. So we have the pair of 4s. That's just a number. We have the 4. The way we're always going to write this is next we're going to write the imaginary unit I outside of the radical, not at the end, because then it's tough to tell where it is. So we have 4i, and then at the end we'll have our 2 that's left over, that's inside the root. Okay, so 4i root 2. Okay, so again, we're always going to write it this way. If there's whole numbers, that goes in the front. Then if there's the imaginary unit I, then that goes next. Then our radical at the end, 4i root 2. Okay, let's practice this. So let's try square root of negative 20. Okay, so the first thing we're going to do, we're going to rewrite this as root 20 times square root of negative 1. We're pulling out the square root of negative 1. And because we know square root of negative 1, that's just I. Here, we break down our root 20. That'd be 5 and 4. 4 can break down to 2 and 2. We have our pair here that pulls out. We still have the 5 left over. So we write this as 2 in front, then our I, and then the 5 is left over, root 5. 2i root 5. Why don't you guys try to do this one, square root of negative 75. Okay. And first thing we do, pull out the square root of negative 1. That's just I. Then square root of 75, break that down to 25 and 3. Okay, then 25, that's 5 and 5. So we have our pair of 5s there that'll be in front, 5. Then we have our I. Then left over we have root 3. That'd be our answer. 5i root 3. Okay. All right, so for tonight, we're just going to do the practice problems associated with these topics. So we're on page 59. We're doing questions 1 through 6.